Hi, I'm Satish Hariharan, Product Manager for Outdoor Systems at Alpha Technologies. In this video tutorial, you'll gain a basic understanding of the three types of distributed antenna systems along with their strengths and weaknesses. The three types of distributed antenna systems are passive, active, and hybrid. Here we have a visual representation of the three DAS architectures, which I'll now explain. A passive DAS network uses coaxial cables to distribute the RF signal throughout each floor of a building. It consists of a number of passive components such as couplers, splitters, and dividers to divert a fraction of the RF energy throughout each floor of a building. Basically, there are no electronic components required to set up a passive DAS network. Now we'll look at the strengths and weaknesses of a passive DAS network. On the strengths, setting up a passive DAS network is less complex as compared with active or hybrid. Coaxial cable used to distribute radio signals is inherently capable of supporting multiple carrier frequencies. On the weaknesses, in a passive system, the radio signal quality degrades the farther the cable is from the RF source. It is not well suited for large facilities with long or complex cable runs. Passive systems do not offer end-to-end monitoring and management. And finally, passive systems are more difficult and expensive to install due to their heavy and rigid cabling that may require special cable raceways or hangers. In an active DAS network, the RF signal is converted to an optical signal through a conversion unit typically located at the head end or the BTS hotel. It is then transported via fiber optic cable to a remote access unit commonly referred to as REUs. The REUs then reconvert the signal back to RF, amplify the signal, and use coaxial cable to connect to the antennas. Now we'll look at the strengths and weaknesses of an active DAS network. On the strengths, active DAS delivers strong and consistent signals at every antenna point, no matter how far away they are from the signal source. Active systems provide remote monitoring capability via SNMP to provide status of all remote antennas in the network. Active systems are ideal for large buildings and they can extend for miles with no end-to-end signal loss. And finally, active DAS can be less expensive and less disruptive to deploy because they use standard fiber optic cabling that are easier to run across ceilings and in tight spaces. On the weaknesses, multiple sets of electronics may be required to support all service providers, wireless technologies, and frequencies. A hybrid DAS network is a combination of both active and passive. The main difference is that it uses a number of passive components such as couplers, splitters, and dividers to connect more than one antenna to a single REU than active DAS. Now we'll look at the strengths and weaknesses of a hybrid DAS network. On the strengths, signal strength at any given antenna point will be higher than passive, but there will still be variability in signal strength and coverage. On the weaknesses, hybrid systems have the same signal loss issues in the horizontal cable runs to individual antennas as a passive system. They're also more difficult and expensive to install due to their heavy and rigid cabling that may require special cable raceways or hangers. And finally, hybrid solutions offer management between head-end and remote units at each floor, but not between remotes and individual antennas. Well, this concludes the video tutorial on the DAS architectures. Stay tuned for more tutorials to be loaded onto the DAS landing page on the Alpha website at www.alpha.ca. Thank you.